We saw how to compute exponents with I as the base, I to the m. Let's now look at how our other operations like addition, subtraction, multiplication, and division work with our new number. We will start with addition. Let's look at the example I plus I. Well, if we had one cat plus one cat, we would have two cats. And if we had one antelope plus one antelope, we would have two antelopes. So if we have one I plus one I, we have two I. But what if we had more? What if we had 3i plus 2i? Well, by the same logic, if we had 3 cats plus 2 cats, we would have 5 cats. So if we have 3i plus 2i, we have 5i. The logic we are using here is the same as when we compute 3x plus 2x. We're adding the 3 plus 2 first and then multiplying by x to get 5x. This logic we're using here is factoring. And just like we can factor out x to add two multiples of x, like above, we can factor out I to add two multiples of I. And numbers that are multiples of I, of the form b times I for some real number b, are called imaginary numbers. What we just saw is that if you add two imaginary numbers, the sum is another imaginary number. We've also seen, for mostly the rest of our life, that if we add two real numbers, the sum is a real number as well. But what if we add a real number with an imaginary number? For example, what if we have 2 plus 3i? Well, just like we cannot simplify 2 plus 3x at all, we can't simplify 2 plus 3i. The sum of a real and imaginary number is called a complex number. In general, a complex number is a number a plus bi, where a and b are both real numbers. We call a the real part and b the imaginary part. It's worth pointing out that even though b is a real number, we call it the imaginary part because it gets multiplied by I. So, what if we add two complex numbers? For example, what if we have 1 plus 2i plus 6 plus 4i? Well, we're only adding here, so we can add in any order. We can do 1 plus 6 plus 2i plus 4i. Now we know 1 plus 6 is 7, and we just found that 2i plus 4i we can add to get 6i. So we have 7 plus 6i. So we found that 1 plus 2i plus 6 plus 4i equals 7 plus 6i. And we computed this by adding the two real numbers and adding the two imaginary numbers separately. It's also worth pointing out that when we add two complex numbers, we get a complex number back, not something new. And what if we subtract two complex numbers? What if we have 1 plus 2i minus 6 plus 4i? Well, here we can distribute the negative sign and rearrange. So we have 1 minus 6 plus 2i minus 4i. 1 minus 6 is negative 5, while 2i minus 4i is negative 2i. So we have negative 5 minus 2i. So we found that 1 plus 2i minus 6 plus 4i equals negative 5 minus 2i, where we subtracted the two complex numbers by rearranging and subtracting the real parts and the imaginary parts separately. Notice again that when we subtract two complex numbers, we get a complex number back. Again, not some other new number.